Welcome back to Safeguarding the Flow of Quality, the podcast where we explore the science, systems, and decisions that protect dairy and liquid food quality from farm to finished product. I'm your host, Mara, and today we're talking about something that influences every touch point in production: water quality. Whether it's the water your cows drink, the rinse water in your parlor, the water used for cleaning, or the water in your processing line, how you monitor and verify water quality make a massive difference in both animal health and product safety. To understand its impact, we need to examine what water quality truly means and how integrating it into your quality system keeps you ahead of potential problems. Let's start with a simple question. Why does water quality matter so much? Because water is woven into everything. If you're a dairy producer, it supports your herd every day, from hydration to milk letdown. If you're a processor, it's one of your most essential utilities, used for cleaning, cooling, formulation, and sanitation. And the key point is this: water isn't neutral. It can become a pathway for risk. It carries minerals, microbes, and organic material. And even when it looks clean, it can still introduce issues you don't see coming. When water quality slips, the impact can show up in a lot of places. It can affect animal health, skew lab results, interfere with cleaning performance, and in some cases, contribute to contamination in finished product or environmental samples. That's why water quality isn't a nice to check. It's a strategic part of your quality foundation. And this is not just theoretical. We've seen firsthand how water quality can quietly become the root cause of a bigger milk quality problem. A dairy farm we worked with had elevated preliminary incubation counts in its raw milk, which directly impacted their bottom line because they stopped receiving quality premium payments. They had already checked the usual suspects: cleaning routines, equipment, and protocols, but the issue kept hanging on. Once they installed sampling systems for troubleshooting and began sampling at multiple points through the milk path, they were able to isolate where the preliminary incubation counts started to spike. It traced back to well water being used to backflush equipment between cows. After they addressed the water source, the preliminary incubation counts dropped and the premiums came back. And water quality issues do not affect only farms and dairy processing plants. Another example of water sneaking in and causing issues comes from a local brewery that was getting inconsistent test results when they cultured their final CIP rinse water. Some days the results spiked, other days they were low, and it looked like random noise. The problem was not their process, it was the way the sample was being captured. The valve was not aseptic, and the collection container was not sterilized. Once they switched to an aseptic, representative sampling approach, the random spikes dropped way down. More importantly, when an elevated result did show up, it actually meant something. That gave them reliable data to decide whether to run another CIP cycle, troubleshoot further, or confidently move forward and protect product quality. Once we understand why it matters, the next logical question becomes, what does good water quality actually look like? Good water quality is consistent. It's appropriate for its intended use, and it's validated with meaningful data. On the farm, that means your herd isn't exposed to pathogens, excessive mineral loads, or chemical contaminants that can affect health or milk yield. In the processing plant, it means the water used for cleaning, cooling, and product contact doesn't introduce microbes that undermine sanitation or distort product testing results. And here's something that's often overlooked. The same water can be safe to drink and still pose risk to your process. Bacterial levels or mineral content that meet drinking water standards might still interfere with CIP performance or reduce the effectiveness of certain sanitizer chemistries. That's why water quality monitoring has to align with how you use the water, not just whether it meets baseline regulatory thresholds. Let's talk about practical monitoring. stuff you can do without overhauling your whole system. First, start with regular sampling that makes sense for your operation. On the farm, that might mean testing water sources that cows drink from, or water used to rinse equipment. In the plant, it means checking water used for CIP, makeup water for product contact, and even water used for environmental monitoring preparation. When you evaluate results, focus on indicators that actually influence risk. That includes microbial presence, such as total bacteria counts or coliforms. It includes total dissolved solids, often referred to as TDS, which reflect mineral load and can impact sanitizer performance. It includes pH levels that affect cleaning chemistry, and turbidity that may signal organic load. Water testing should not be a once-a-year checkbox. It should be part of a rhythm, whether that means seasonal checks, testing after changes in water source, or following maintenance events that could affect your distribution system. Most importantly, connect your findings back to the biology and processes you care about. If you see a spike in bacterial indicators, do not just record the number. Ask what that means for herd health, cleaning effectiveness, or finished product risk. But monitoring alone is not enough. This is where verification comes in. Verification is what gives you confidence. It is the step where you close the loop between testing and action. On the farm, that might mean adjusting cleaning and inspection of water troughs, or implementing treatment strategies based on microbial trends. In the processing plant, it means confirming that your water consistently supports effective CIP cycles, does not interfere with sanitizer chemistry, and does not compromise environmental monitoring results. One practical tip: if water quality changes, even slightly, view that as a potential root cause when troubleshooting cleaning performance. Rather than assuming a sanitation failure first, consider whether the water itself changed the dynamics of your cleaning chemistry. Verification isn't a single moment. It's an ongoing process of asking, did this water deliver the result we expect? Do our actions match our standards? And do we have the data to prove it? At the end of the day, water flows through every piece of your operation, yet its role is often underestimated. When you elevate water quality from a checkbox to a strategic asset, you unlock a smarter way of protecting animal health, product safety, and process performance, whether you're on the farm or in the processing plant. To learn more about water quality monitoring and verification, visit QualiTru.com for our guides, tools, and resources designed for producers and processors alike. Thanks for tuning in to Safeguarding the Flow of Quality. Until next time, stay curious, stay proactive, and keep every drop working for your quality system.